stand to the side. Thanks.
I'll put these on the back table here.
The next two presenters are Brian Porter and Scott Nelson. These two gentlemen are with Wisconsin DOT and are really on the front line of these kinds of issues and questions. So Brian joined Wisconsin DOT about 5 years ago and had worked as an engineering consultant for about 10 years. His background's in traffic operations and safety engineering. He is passionate about employing data-driven decision-making, and I worked with Brian a number of years ago when the push was really for modifying 4 lanes to 2-lane systems, 2-lane cross-sections or twiddles. Brian's got a civil engineering degree from Marquette and a master's in civil from UW-Madison. Scott is the Northeast Region Traffic Safety and Incident Management Engineer for Wisconsin DOT. He's got 22 years of experience with the department, has worked in design, and really has been working in traffic operations in the last 18 years. Scott's from the 3rd engineering school in Wisconsin from UW-Platteville. Gentlemen?
Thank you, Steve. All right, so we're going to talk about restricted crossing U-turns. I'm Brian and Scott here. So why don't we just dig right in. So you guys have heard a little bit about RCUTs. I'm going to refer to these as RCUTs. You heard there's also a J-turn. That's what they're also known as. So what I'm going to do is I'm going to talk about some of the issues and problems we see at high-speed rural 4-lane divided highways. Talk about how RCUTs specifically target some of those issues. Talk about the different types of RCUTs, where they're applicable, and then Scott's going to get into more about some of the design considerations, the locations we have in Wisconsin, talk about how those locations are actually performing from a safety perspective, and then give a few tips on public outreach. So some of this is going to be review. If you heard some of the earlier discussion, there's 2 main types of RCUTs. There's a signalized version, which are also known as super streets, and those, and then also an unsignalized version, which are also known as J-turns. And those signalized versions, those are essentially installed to increase capacity. You're helping to improve progression along a signalized corridor. So you're essentially simplifying the signal operations at that primary signal, and you're essentially separating those movements. So very consistent with access management. The unsignalized versions are more installed to help improve safety by reducing right-angle crashes, which are often, more severe. We're going to focus on those unsignalized versions, the RCUTs and J-turns. So to talk a little bit more about some of the issues and problems that exist, again, we're talking about 4-lane, high-speed, divided highways. And in Wisconsin, we often call these high-speed expressways in some other Midwestern states. So the problem is there's 42 conflict points at one of these intersections. And we've seen 32, we've seen 48. The 42 being that these are almost 2 separate T intersections here at one expressway intersection. So 42 conflict points, and because of the high speeds, we're talking about 55, 65 miles an hour here in Wisconsin, higher in some other states, small errors can have pretty significant consequences. And crashes at these intersections, again, are often very severe. So the most common crash type we see and what we look for to essentially consider an RCUT is where we have minor road vehicles who either want to cross this intersection or they want to make a left turn, they will essentially look to their left, they'll cross those first couple of lanes, and then they'll get hit on those far side lanes. So again, it's almost as if you have two intersections, we're passing through the one, but we're having accidents on the far side. So, left turns aren't just a challenge for these high-speed rural divided intersections. It's for most intersection types. Research estimates 72% intersection crashes involve a left-turning vehicle. It's interesting, UPS actually routes their drivers to minimize left turns. Left turns are not only more crash-prone, but they also incur more delay. So what we've seen is UPS has actually found that they spent $300 to $400 million a year. They save that much money a year by reduced fuel costs, reduced vehicle running costs, wages, by simply routing vehicles around left turn movements where possible. Obviously, a really interesting concept, not always something that we can do as everyday drivers, but you heard a lot in earlier presentations about left turns, how complicated they are from a human factors perspective, and then also from a safety perspective. So another challenge with these high-speed expressway intersections is we're often trying to preserve access along these types of facilities. And with that, with these local and rural roads, they're often going to end up on curves. And even these longer sweeping curves have reduced sight distance. And again, human factors research has found that it's difficult to perceive how close those oncoming vehicles are and then how fast they're closing in on you. So that's just something we're all challenged with. So with those considerations, it's very difficult to judge gaps in oncoming traffic. And that's just another one of the challenges. So another challenge is that these intersections are very wide. You often see, like I said, a minor road vehicle. They'll cross one set of lanes, they'll stop in the median briefly, and then they'll look to cross the second set of lanes. If someone from the minor road pulls into that median, and then you see a mainline driver pull into that median as well, it creates this very uncomfortable situation. And it's not always clear who has the priority and sort of how vehicles are going to proceed through those medians. Semis and farm machinery also add to that challenge. Many of our medians on these rural high-speed expressways in Wisconsin are 40 to 60 feet wide. We have a typical WB 67, 75 feet long. That's obviously, if they want to stop just for a brief moment in the median, they're going to be hanging out the end, and they're much slower to accelerate as well. So again, that creates additional challenges. So when you combine the high-speed traffic with the high-risk left turn movements, the uncertainty in that median, the slower accelerating vehicles, again, small mistakes, even indecision, can have significant consequences at these intersections. So how do RCUTs help? RCUTs target those issues specifically that I talked about by reducing the number and type of the conflict points. So total conflict points go from 42 to 24, and crossing conflict points go from 24 to 4. That's at a traditional RCUT. They also simplify decision making. If you're on the side road, again, and you want to make a left turn or a crossing maneuver, you're going to look at that first set of lanes. You're going to make your maneuver, get into the U-turn storage pocket, and again, you're separating those movements, separating the decision making. That also eliminates those more risky left turn movements. So instead of having all of the movements at that main intersections, again, RCUTs separate those movements, which provides space for trucks and other farm machinery to store completely in that U-turn storage pocket. They're also not exposed. They eliminate that uncomfortable situation of multiple vehicles coming into the median opening and all having to kind of jockey for space. R-cuts also preserve full access at the intersection at a much lower cost than, say, building an interchange. Also, a traditional intersection can be retrofit fairly easily to an R-cut, often without acquiring additional right-of-way. So that's a significant advantage. So where are they applicable? Unsignalized R-cuts are most applicable at those, again, high-speed, 4-lane divided expressway intersections where there's minor road stop control. We look for locations where the side road ADTs are between 500 and 4,000. Also, we look for a history of, again, those far side angle crashes at these intersections. At these types of intersections, a traffic signal or a roundabout really isn't an option. You know, we're trying to move traffic. This is kind of on the mobility end of the spectrum on the access versus mobility. As traffic volumes increase, and this is something I borrowed from NCHRP 650, as traffic volumes increase, we might look at signing or marking enhancements. Again, maybe offset left turn lanes if there's crashes or other issues with left turning mainline traffic. You know, obviously if volumes are so significant that we need to move toward an interchange, we can do that. But what we're finding is significant safety performance benefits out of these R-cuts at a much, much lower cost than what you would for an interchange. So Scott's going to talk in more detail about R-cuts in Wisconsin, how they're performing, and we'll answer questions after that.
Thanks, Brian. So now next, I was just going to kind of walk through the Wisconsin experience. So again, I'm a regional safety engineer in the Northeast region, so a lot of these issues that come through here. So interestingly, in Wisconsin, we actually have about 3 different types of R-cuts that we've been utilizing in Wisconsin. So our traditional R-cut kind of has long distances between the intersection and the actual median U-turn. You know, generally we're talking about 1,500 feet to make that maneuver, which gives people enough time to make their merge and move over. So basically it requires the main line to be making a lane change. But again, our philosophy with the R-cuts is very similar to a roundabout. We're just trying to simplify the driving task. Instead of coming to an intersection, you're looking to your left, looking to your right, looking across, who's turning left off main line and trying to process all that to find a gap. We're just going to simplify it down to just making traffic in one direction at a time. So here's our traditional R-cuts. The other one that we've had some experience with here now too is what we call our median U-turn R-cut. So this is a little bit shorter. Instead of having that 1,500 feet between our median U-turns, we're bringing it down to about half of that, about 800 feet. And if you notice, we don't allow any direct left turns from main line with these intersections. So if you're on the side road, you still got to make the right turn. But if you notice, we have a left turn pocket that begins initially. So instead of just going one lane, making a lane change, and then getting your left turn pocket, with these median U-turns, you're actually going to cross both lanes, get directly into the left turn lane, goes down that 800 feet and comes back across here. Once again, you're facing traffic, only dealing with traffic in one direction. And if you're going to make that turn with your destination being across, the crossing maneuver, you can turn right into the right turn lane and go up to the intersection. So you're really not impeding main line as you're merging into traffic or diverging out with this median U-turn. But again, we do lose the direct left turn lane at the intersection itself. And the other one we have is a hybrid. So in our facilities development manual, we talk about all 3 of these options. But basically, this is just a combination of the 2 we talked about before. So again, this distance here, again, is generally more in about the 800 feet. So it's the exact same thing as the one we talked about before, except we still do allow those direct lefts at the intersection as well. This one takes a little bit more signing where you have 2 consecutive lefts if you're traveling down main line. But again, when you're trying to sell these things, this is a good option because it's providing all the alternatives, at least to get you into the site. So just quickly, we have 7 RCUTs that have been built in the state of Wisconsin. You can see starting back in 2011. So when we get into safety data, some of our after safety data is a little bit more mature than others. For those of you that are not from Wisconsin, this doesn't probably mean too much to you, so we put the Minton map up here for you. And you can kind of see here's the locations where we have our RCUTs. The red are our traditional ones. The median U-turn is the purple. The hybrid is right in the center of our state, right at the Portage-Wood County line on Highway 54. And then there's a couple that we have proposed here as well. So we're not significantly in the RCUTs, but we're making progress. And we hope we'll have some opportunities for some more. These next couple slides, I was just going to show you an example of each. So again, here's our traditional RCUT. This is Highway 53 and B in Douglas County, the very northwest part of our state. And again, this is your very traditional RCUT. All movements available from mainline. And if you're going from the side road, no crossing or lefts. And you can also notice that we have a little bit of a wider median here as well. I was going to mention on this one, we also have one of these at 57 and C. And it's worked very well for us because it's in a huge horizontal curve like Brian talked about. And the nice thing about that horizontal curve is we were able to get those median U-turns to occur beyond the PC and the PT of those curves. So therefore, they're looking tangent down the road, and we take that horizontal curve out of the equation where we know drivers make errors in trying to accept that gap. Here's our median U-turn. Once again, this is the one that has the median continuous left turn lanes and right turn lanes, and you'll note the median is completely closed off here, so no turns from mainline. This works a little bit better if you don't have heavy mainline left turns. If that's a little bit of a lighter move, making them go down to the median U-turn. Again, we reduce those conflict points down even more. And then here's our latest RCUT that's been built in Wisconsin at 54 and U in Portage County, kind of the Portage-Wood County line. And here you can see, again, it's the hybrid design where we're allowing all movements from mainline here at the intersection, but we still have the continuous left turn lane and the continuous right turn lane here. All right, so how are we doing in Wisconsin? So again, what we try to do is we try to look at 5 years of data before these RCUTs were built, and then we try to look at and put it into an average per year, and then how we're doing on an average crashes per year after we implemented these RCUTs. So you'll notice basically our fatal and injuries, we actually did have some fatals, but they were outside our 5-year window here, so it actually shows 0. But when you look at our injuries compared to what we're seeing today, and our severity charts, obviously A, B, and C from most severe to least severe, you can see a pretty significant reduction in injuries. You know, we're talking almost a 90% reduction in injury and fatal crashes, 20% reduction in total crashes. So you will note we have a few more fender benders going on, but we're really targeting these severe injuries. It's been very successful from that perspective. Interestingly, 29 in VV, this is the one that Gilbert, you'd actually had mentioned in Brown County in an earlier presentation. This one, if you notice, our crashes, once again, you know, our property damage have almost doubled here. So you kind of scratch your head and say, is it really doing what we hope to do? But then once again, if you look, nearly 2/3 of our injury crashes, again, have been reduced from that. So it's been very successful from a severity standpoint. And this one does handle a substantial amount of traffic. So if you actually took that one out of there, you know, our performance is even, you know, it's almost ridiculous with a 96% reduction in injuries. And keep in mind, that's at the intersection and the 2 median U-turns, not just a single intersection in the before condition. So we've been doing very good in Wisconsin. We've had very good luck. And we feel really good about how they've been performing. I apologize on this slide. I got a little bit of something happened on there. I'm sure it was the computer. It wasn't me. But just a couple other national studies in North Carolina. It depends how these studies report out their statistics, but they've had a 34% decrease in total crashes, that 58% decreases in injury and fatals, the 86 is angle crashes, and the 75% is in left turn crashes. Maryland, once again, injuries about 42%, and Missouri, the injuries are down about 54%. So you can see Wisconsin is actually performing very well and comparable to these other states as well. Okay, public outreach. I just put a couple of these slides in there because these aren't always the easiest sell for those of you that have went to some of these public information meetings. As Most of you probably also know that anybody that has a driver's license is officially an expert traffic engineer, and they generally know more than any actual traffic engineers. So it's always a challenge when you go to these. And I guess the big thing I would always say is, like Brian talked about, we're trying to address far side right angle crashes, which is a very difficult crash to correct. And there's not a lot of tools in the toolbox when we come to these, short of, you know, massive, very expensive interchanges. So when we start getting to the capacity and the crash issues, in the delay issues, I always feel like this solution kind of leads itself down the path because there's not left there. It's kind of a do nothing, or you go this method. You can try doing some signing and marking changes, but we have not had a lot of success with reducing crashes with what I'd call the cosmetic issues. Likewise, if you have trucking industry in there, the delays could be less at these J-turns than they actually are what they are experiencing today, once again, because they can't do two-stage gap acceptance because of the median width. So again, the other thing I would just mention when you're talking about RCUTs, they're not access restrictions. I would be very clear that all the access to that business or the side road that existed before the intersection will still exist afterwards. You can still turn left from main line, go through, turn right from main line. None of that's changed. When you're on the side road, you can still turn right just like you could before. The only thing we've changed is a crossing and a left turn maneuver from the side road, which can still occur. It's just been displaced downstream, you know, between that 800 and 1,600 feet. So it's addressing our safety issue. It can help with our capacity issue. It reduces delays. And overall, they've been performing very well for us. But there's still a challenge when we go out there. They're not just widely accepted that, yeah, this is a great idea, let's move forward with it. So we have to work through those issues. And with that, I'll be happy to answer any questions, Brian or I, if anybody has any. Yes, sir?
I have a question. I looked at your before crash data. Even the total number reduction percentage is very high, but before condition, the crash number of crash is also very low. So
Yeah.
I don't know what's the typical decision making procedure if you select this location to implement the outcome based on what?
What's it? Yeah. Okay, so the question was, again, it appears that the percentage reduction is very high, but the actual number of crashes reduction is very low. And I think probably the answer to that question is generally these crashes that do occur are higher severity when they do occur, so they get more attention and more concern from the public. It's kind of a good thing that we don't have a terrible situation where we're having, you know, like a fatality per year or those suspected serious injury, the type A's per year. It's less than that. But when we look at our expressways, when they do occur, they're pretty severe, and we get a lot of concerns and complaints and the uncomfortableness. A few of these other locations we had are locations where during rush hour, you're seeing multiple people stacking in a median, and people are making poor choices as they pull out, and there's these near misses and stuff happening as well. Not all of these were safety driven. Some of them were based on development and stuff coming in as well, where we're trying to get in front of it. So they weren't all safety driven improvements either, I guess would be part of the answer as well. Yes, sir.
So when the PDOs go up, where exactly are those PDOs occurring?
Yeah, that's a great question. And interestingly, like 29 and VV, the majority of those crashes are on the side road, making a right turn. The first vehicle pulls up to the line. The second person's in behind them. They think the first person has left because they had a gap, and they're looking to their left, and they're coasting ahead, and they're rear-ending them. So quite honestly, one could argue whether or not that is actually a R-cut related crash or not, because that crash occurs at any even conventional intersection. So we have very few of them that are actually occurring where the median U-turn's occurring. The majority of our crashes really are just rear-end crashes on that right turn from the side road approach.
Was that a stop control both before and after?
Yes, correct. Both times it is. So it really hasn't changed much. And I guess from my perspective, I see that crash, you know, a lot of our interchanges, we have that one. It's just kind of a bad habit of our drivers to always be looking left and not realizing whether or not that first car actually did leave or not.
You're not seeing it in the weeds?
No, very, very, very little. At least in my region, I would say very, very little. We do get complaints and concerns from citizens that use a few of those intersections that they have a hard time sometimes getting over as they're accelerating. And I think that's why our hybrid, as well as our median U-turn, has been a little bit more accepted. You know, at first we're a little bit hesitant because you're crossing two lanes to get into that left turn pocket, but it does seem like our drivers have a more comfort with that because then they're at least right into that left turn. They're not infringing with the excel, decel, and trying to get across that lane of traffic. Yes, sir.
Do you have a rough idea by how much would that increase the delays?
How much it decreases the delays? No. It's a question.
I'm pretty sure it would increase the delays, right?
Well, you know, it's only during non-peak times for them to drive down and turn back around, you know, you're talking a minute, probably. You know, minute, 2 minutes, maybe at most. And again, depending, you know, we had at least a couple of these locations where we had some pretty long delays before this. It's probably not much different, but we didn't do any official delay studies before and after. A few of these locations are starting to develop, so we're gonna maybe see a bit more delay. And again, this solution here for these are generally, we're talking about, I'll just say $750,000 roughly. The median U-turns might be like $600,000. The one at 29 in VV, if we build an interchange there, we're looking at $20 million. So, you know, it's a fraction of the cost compared to that big solution. Sometimes we have to go to that solution, but, you know, when you try to be good stewards of the taxpayers' money and try to use the best of the resources you have available, it's a pretty enticing solution. Yes, one more.
For the U-turn locations, have you had any site distance problems, and if so, what have you used for your criteria?
Site problems?
Site distance, the intersection site distance at your U-turns.
So the question was if we had any intersection site distance issues at the median U-turns. The only one I'm familiar with was the one I talked about earlier at 57 and C. And again, if you looked at site distance criteria, it met it. It was just fine. It's just in the middle of a huge horizontal curve on the expressway system. And again, on that case, I believe those median U-turns are actually about 2,100 feet away from the intersection. But we made that conscious decision to do that just to get it completely out of the horizontal curve. So now when they get to that median U-turn, they're on a perfect tangent, and, you know, they can see a half mile or better.
So you actually have criteria for U-turn movements, the site distance?
We do not.
In the green book, we don't have that.
We do not. Again, that particular location did not have a site distance restriction. We were just seeing the human error of that horizontal curve, the human factors issue, that people were just having a hard time judging gaps. And that gave us an opportunity with these RCUTs to basically take that out of the equation. It's a non-factor now.
I was wondering how you fund these?
Yep.
And is it by the region proposing these, or is it part of construction?
Yep, so the question is, how are these funded in Wisconsin? And I would say there's kind of a variety of factors. A lot of these have been HISUP funded, you know, Highway Safety Improvement funded. And the way our program works in Wisconsin, it's based on a simple before and after analysis based on severity. So we look at the type of crashes occurring before and how many we can correct and kind of what the cost is to do that correction, and we work through that. So a lot of them got prioritized through Highway Safety Improvement funding. Other ones go through our normal, either normal 3R funding, which is our standard resurfacing rehabilitation program. Any other questions? Yes.
How many more do you have on tap?
Do you know offhand how many we have?
Probably another half dozen.
Yeah, I would say about half a dozen probably that are working through the system or the process, yeah.
Okay.
All right, thank you.